There we go. Okay. Right. Can you explain what N and R again? Okay, sure. So basically, N is the number of possibilities for each item in the list, and R is how big that list is. Does that help? Or okay, cool, awesome. So like in this case with the 5 people, each person, you know, there's 365 possibilities, 365 days. And there's 5 people, we're asking each of them their birthday, so R is 5. Good question. Any other questions? Okay. All right, anyway, so let's keep going. That was with 5 people. Okay, that's with 5 people. So now let's, so now let's kick it up a notch and consider 30 people. Let's kick it up a notch and get 30 people now, okay? So we want the probability. So again, you're in a room now with 30 people. You want to know, and the experiment is you're asking each of them when their birthday is, okay? You're asking each of them when their birthday is, okay? So the sample space, since there are 365 days in the year, the sample space would be this. That's how big it is. You know, for each person, each day is a possibility. So there's 365 raised to the 30. I was going to say, okay. Not only that, we want to know the probability that all of them have different birthdays. Okay, so again, order still matters here. That's what I was trying to show you on the first slide. There's 30 people now, so we use this. T of 365, 30. That's how many outcomes there are. And so the probability then would be this. That's what the probability would be. Yeah?
Could you calculate 365, 30 without like writing all of the numbers? Like,
you mean the numerator?
Yeah.
Okay, I'll show you. Let me get to the Desmos calculator. I mean, you could use the, oh, I got nervous. I thought it wasn't sharing. You could use the factorial formula, but let me get to the Desmos calculator. Basically, you know, you go to Desmos. Oh, wait, you know what? Let me share it actually. Okay, let me stop sharing. I did email the notes as well. So you should have it in your inbox. It's up there. It is. Desmos. So if you go to Desmos, this is the Desmos site. You go to Math Tools, and you go to, let me see, Scientific Calculator. Click here. Okay, so you should see that. So what you can do is, let's see, if you press where's function, F-U-N-C, okay? Where is it? Up down here, see, NPR. So if you want that probability one, excuse me, you want the 365 with 30, you can press that. And this is the same as P of NR. This is the notation they use in the book. I wasn't able to use that notation though, so that's why I'm using the P of N comma R. But anyway, from there, you can type 365, then you type a comma, then you type 30, and you can see the answer will be there. Or if you press enter, you got it here as well. Does that help or?
Yeah, thank you.
Yeah, I know that number's kind of nasty. I understand that. But what's nice also is you could just divide it by, see, if you, let me see, where's division? If you, oh, where's division? Okay, in main, you could press division. So here you would have to use it, I guess. If you have that again, let me just write it out. Here we go. Then what you can do is you can divide by 365 raised to the 30, and then you get your answer. So, if you need help with it, don't be afraid to ask me. I mean, I hope this helps at all, what I'm doing. I hope this helps, I mean. So, but you can use the Desmos calculator is what I'm saying. I know you can also download it onto your iPhone. That's what I did. So, I hope that helps.
Yeah, that helped. Thank you.
All right, good. Okay, any other questions? Okay, let me get back to the, oh, yeah.
Have to use the Desmos calculator, or is there a way to do that on the regular graphing calculator?
What do you mean by regular graphing?
Like the regular, like Texas Instrument one. Like, is there a way we can do that same NPR?
I want to say yes. I just don't remember how. I think what you can do is I think there should be like a catalog or something, and then you look for the NPR function, I think.
Okay, thank you.
I think so. Don't quote me on that though, but I'm sure if you look on the internet, you'll be able to find like help with that. So, okay. Any other questions? Okay. Let me stop this. Okay, so let me stop this. Let me go to with the lecture notes. There we go. Okay. All right. I mean, remember also that, let's see, where is it? If I go back to the first slide, let me show you what I mean. There's also those factorial symbols and stuff. I know factorial is in the iPhone calculator. I mean, you have to turn your phone onto the side or whatever, like, to see it. But I do know it's there. So the worst thing is you can always use this formula. So I just chose this formula because the notation this notation, because the notation they use in the book, I couldn't get onto the slide. But that's why I thought this one was okay. So, all right. Okay, so this is what we have. So this is that probability. This is the probability that. So this is the probability that if you have 30 people in that room, this is the probability that all of them will have different birthdays. Okay. But now, to get to the actual birthday problem, that's a little bit different because there you want the probability that there's at least one shared birthday. In other words, the actual problem is at least two or more people share a birthday. And that's not what we calculated. We calculated that all of them are different. But it turns out we have this formula. Namely, the probability of an event happening at least once is related to the probability that the event never happens by this formula. It actually turns out, as I wrote there, those two events are complements of each other. Remember how if you have an event and its complement, the probability of the event plus the probability of its complement is 1. And from there, you can get this kind of formula. Basically, the complement of something happening at least once is it never happens. And that's really where this formula comes from. And the reason we care about this is because usually it's a lot easier to determine the probability that an event never happens than it is to calculate the probability the event happens at least once. So in other words, this one's a lot easier to get usually than this one. And if you get one of them, you get the other one. So from what we just did, we found the probability that the event never happens, the event that what is it? That they have a shared birthday. In other words, the probability that at least one shared birthday exists. See, to get this, we have the probability that there are no shared birthdays, and we do 1 minus that. So the event here would be there's at least one shared birthday. And that event not happening is the same as saying there are no shared birthdays. If no one shares a birthday, right? That is, if there is not at least one shared birthday, and there's no shared birthdays, and that's what we calculated. So the birthday problem, this one, is 1 minus what we did, which turns out to be this. That's what that turns out to be. So